Once you learned how to find the determinant of a 2 by 2 matrix, there's a good chance you pictured it, or perhaps even wrote it, like this, with diagonals. It's pretty easy, right? It's the product of this diagonal minus the product of this diagonal. Considering that, it produces the correct formula for the determinant. So certainly, finding the determinants of 2 by 2 matrices is really easy. 3 by 3 matrices, on the other hand, is a bit more of a headache. Link in the description to videos going over how we find the determinant of a 3 by 3 matrix. We do it with a cofactor expansion. It's not particularly fun, however. It would be nice if there was a similar trick for 3 by 3 matrices. Well, good news. It turns out there is, and I'll show you how to do it. The gist of the trick is this. Duplicate the first two columns of the 3 by 3 matrix and put them to the right of the matrix. Then it's easy to express all the diagonals involved in this computation. So here's how you calculate the determinant of the 3 by 3 matrix. You take this rightwards diagonal, and this rightwards diagonal, and this rightwards diagonal, and you should be multiplying across each rightwards arrow and adding all of those together. And then do the same thing with these leftwards arrows. So that diagonal, that diagonal, that diagonal. Take products along those diagonals and then subtract the red ones from the blue ones. So add up the products on the blue diagonals, subtract the products on the red diagonals. And here that is written in words. We'll multiply the entries on the rightward arrows and subtract the products of the entries on the leftward arrows. If we carry out that process, we will be doing exactly this, just in an easier to remember way. And certainly, this is not the catchiest formula in the world, but those arrows are pretty easy to remember indeed. So let's do a quick example, starting with a 2 by 2 matrix. How do we find this determinant of a 2 by 2 matrix? Just multiply along this diagonal, 2, and subtract along the other diagonal. That's negative 12, so subtract negative 12. The determinant of this matrix, then, is 2 plus 12, so 14. All right, now let's do the more interesting example. Let's try out our new diagonal trick on this 3 by 3 determinant. First, we duplicate the first two columns and put them over here to the right of the matrix. We're going to have to multiply across these diagonals and add those up. So let's do that. 1 times negative 2 times 2, that's going to be negative 4. And then we have to add that to 8 times negative 1 times 0, that's 0. Then we have to add that to 3 times 4 times 4, that's 48. Now we have to start subtracting, going the other way. 3 times negative 2 times 0, that's 0. Then subtract 1 times negative 1 times 4, so negative 4. There's two negatives here, that's fine. Then subtract 8 times 4 times 2. That's 64. Run the numbers. This 3 by 3 determinant is negative 4 plus 48. Okay, that's 44. Plus 4, that's 48. Minus 64, that's negative 16. So that's a pretty handy trick for 2 by 2 and 3 by 3 determinants. Unfortunately, there is no such trick for 4 by 4 determinants. Just got to do those the old-fashioned way if you're not going to use a computer. One more thing, with the 3 by 3 determinants, if maybe you don't like duplicating the first two columns, you can try to get in the habit of just visualizing how the diagonals come back around. So it's like this, and then the next one is these two, and then it comes back around in the corner, and then this comes back around over here, just like that. Meanwhile, the ones we subtract go this way, and then this way, but wrap back around at the top, and then this way, but wrap back around over there. So if you can visualize that, you can skip the rewriting of the first two columns, which can help save some time. Let me know in the comments if you have any questions, and be sure to check out my Linear Algebra course and Linear Algebra exercises playlists in the description for more. And consider joining Wrath of Math as a channel member to help support what I do and get access to these lecture notes that you see in my videos. Thanks for watching.
I'm the mathematical menace, the machinations of mankind. Two calculators at the same time, hand signs and abacus, finger count and calculus. I'm the V to the T, my parameter, the rapidest. Happens like this, my lecture's the most prominent, dominant. Call me De Morgan, I get the compliments. The union in together like any time that we intersect, cause my opponents know they need